ransomware attack, this is another way to start looking for trouble. And the way I like to do it is to start from Suricata in the first place. So we have this intrusion detection system. We might as well look at it and see what it picks up. So I start again just right at the beginning of search, and then I look at the data summary and go to source types and look at Suricata here. So there's 125,000 Suricata events. So as usual, I'm going to sample them and get an idea of what might be here over all time. And now I can see the type of Suricata event is going to be down here. Event type, yeah. And here's an event type attack. That's probably good to look at. Let's try that. And the signature shows me what's going on here. Malformed request data, server, possible CVE attempt. All right, so this looks like interesting stuff. And let's get rid of the sampling now and look at them all. All right, and the signature is here. So you see script tag, on mouse over, possible CVE attempt, and so on. All right, and there is a ransomware attack here, which you can see. I'm just looking for more ways to filter it down. Severity, for example, there we are. Let's try high severity. And here's the signature. Various things happening. Let's look at the rare values. And here, this is what I was looking for. You'll see some of this serverware, ransomware server events, which is your clue. In the instructions for the flags, I just started you with the information that you had server, but this is how you would find it if you didn't know. You just look through the high value events and you see there is server. So now you can search for the server events. And let me go back to my instructions. All right, so search for server and the source type associated with Suricata. And we already done that one. And so anyway, now we can find the domain. The part that I thought was very interesting is we can find the exactly where this malware came from, the VB script and all that jazz. So let's look at Suricata events on 24 August. So I'm going to go to back to the start, search. Back to Suricata, okay, and turn on sampling and restrict it to the 24th of August. '08-24 and '08-24 or 25, 2016. All right, there we go. Apply that. All right, and there are some events. And now I want to look at the source IP field and go to the source IP of our known source of the infection, which was that one endpoint. Here's source IP, and it was this one, 250.100. We can restrict ourselves to that. And now look at event type and load web pages. All right, so there's HTTP. And look at the host names. Well, I'm seeing a lot more than I should, 38. Goodness. Let's get rid of the sampling. All right. perhaps that's the wrong address. Let me stop and check that again. I'm just going to repeat I'm going to save this query in a text editor. And I think I must be looking at the wrong address because I see far too many events. So let me repeat what Caitlin did earlier, which is look for this We8105 desk. And by the way, there's another way to do that I prefer. This is not listening to me. Come on. Okay. We8105 desk. And what I would do here is go to source type and look at LDAP. That's the Microsoft directory traffic, and that'll tell you what it is. And the source IP of this stuff is going to be the IP we want. So it is 192.168.250.100. All right. That's what I did stream, find events on that day and look at their IP addresses. All right. So anyway, I wanted to find the suspicious domain visited by them. And I'll go back to this query and we'll see if I can overcome my difficulty with finding too many events. So this is the Suricata HTTP events. All right. And I look for the host names visited. Which are here. All right. And so there's a bunch of them. And I want to look at them all, so I'm going to just do a table of time and host names. And that is something host name, http.hostname. All right, I got Microsoft. And this was what I was looking for. I got this funny domain name in the middle of it. That is the domain name that's responsible for this attack. solidarityproximity.org. So that's how you find the malicious one, and you can verify that with open source intelligence again. Just Google that domain. And this will tell you a whole bunch of useful information. Anatomy of a ransomware attack. This tells you about Cerber. So this tells you that it is coming from Microsoft 365 files with macros. And what it does is it drops a VBS file with this, appdatarandom.vbs. Then it launches it using wscript.exe, which downloads this image, mhtr.jpg, and some of the malware is hidden in the image, which they talk about here. There's a whole lot of useful indicators of compromise here. It drops a binary in a hidden folder with a random name, with an exe file, and then it runs that and encrypts all your documents with all these file names, and then it pops up this ransomware message asking you to send your money, and you see the actual domain name doesn't have a .onion in it, which is why we were having so much trouble finding it before. All right, anyway, so
Sam, I figured out the issue. It was the time date range we were looking at actually was incorrect.
Okay, well good. Well, we'll look at that. Anyway, let me do this part here and we'll look at that. All right, so all right, so now if you go back to the instructions here, all right, so we can find the VB script. And now we have that solidarity proximity. We know we're looking for Cerber, so look for events with VB and EXE. We saw it's going to launch a VB script and an EXE. So go back to search, and I want VBS and EXE in the same event. That'll get us to the right area. Is it searching? It is not searching. All right. All right, there's only 16 of them, and here it is, wscript exe, and what's quite useful here is to just make a table of time and command line. And it is command line, and I think I also have parent command line. Yeah, all right.
Yeah, so Sam, remember how we had two time date ranges? One was at
Was
nine.
it the earlier
Yeah, it
one?
was the earlier one.
Oh, well, that surprises me.
That's why we couldn't find it.
Missing a search command. Oh, I have to have table. Oh, I'm sorry. I gave you a bump steer then. All right. So here you see, this is the end of the ransomware attack. These things are currently in reverse order. Let's put them in forward order. Okay. So here it runs a VBS. And here is the malicious file. This is clearly part of the attack. It ran this thing, set app data random. This is a long Windows script file, Windows DOS script, whatever they call it now, Windows command line, that this runs in cmd.exe, and this creates a Visual Basic script with a random name, which you see is 20429 in our case. And then this is the one that is really interesting. This is the original origin of the infection. Was a USB stick, which was inserted and became drive D, and that had a Word document on it called mirandateunveiled.m. This is the original source of the infection, this USB stick. And that then ran this, which created the VBS script, and then it runs scripts and encrypts all the files, and you can see it go through the stages. It makes a temporary file here, which is used to encrypt the local files, and then it makes a thing which is used to encrypt all the network shares it can find. And then when it's all done, it pops up this thing, decryptmyfiles.vbs. So you can really trace the whole process of the ransomware attack here. And that's what I wanted to show you. And Caitlin, are you ready to show them how to find that answer for 4.3 that we couldn't find?
Oh, sure.
Yeah, why don't you just do that? We'll put it on the same video.
Right, okay. Let's see if we can.
I think I gave you a couple of bump steers is why it went off track.
So it turns out we did everything correctly. It was the timestamp. Remember I said in a real scenario you'd want to check both just in case.
Yeah.
So it turned out to be to be the earlier timestamp. Now, the way I actually figured this out was I looked at all the real values for DNS from the source IP. For the entire day. So what I did is I went to the date time range. And I said from the 24th, to the 24th. Let's just grab everything, and we'll go to where limit equals 20, and we're going to get a bunch of. Oops.
You got to give it a field, yeah.
Oh yeah, 20 query. So we're going to look at the DNS queries. And we get a bunch of these like .arpa stuff. We don't really care about that. So I'll say and query and not query equals *.arpa. So that'll get rid of all those arpa
reverse DNSs, yeah.
Yeah, we're looking for. And we'll get all the rare requests that we made. And so we do see the domain here. And so it does show up in that day. And it is rare, and it only happened twice. So if we go back to our date time range earlier that we saw, go back to the date time range, and we switched from 9:48. Well, let's say 9:48 to 9:49. So 1 minute window, 8:24, there we go. We'll give it a 1 minute window, do the same thing again. Boom, there we go.
Well, yep.
And that was the same timestamp that we saw in the other Siri catalog.
Yeah, but that's not the answer for the question. The question is looking for the domain lookup at the end of the encryption, where it asks for the ransomware note, and we still haven't figured that out.
Oh, okay.
So I'll add that later in a separate video. We'll figure it out over lunch. I'm going to stop this one.